Alright guys, so in this video we're going to be looking at numbers 4 and 5 from the test review. And so looking at number 4, let's just go and get started. They're asking us for the measure of angle HFI. And so if we remember the way that we label angles, this should be familiar for y'all. This letter in the middle here is always going to be the vertex, or the point of the angle where the two line segments meet. So angle HFI is the angle that we're looking at right here, from H to F and then from F to I. So really the only one that's not labeled, so that should have been pretty obvious. So we want to know what this angle is. And they give us these two other angles, so we're dealing with these angles that are central angles, so you might remember that term. So these are central angles, and that's because the point of the angle, or the vertex of the angle, is right at the center of the circle. So there's some things that we know about those that might come in handy later, but for right now we know that we know something about circles, and we know that all of these central angles in a circle have to add up to 360 degrees. So if you think about, if you're standing in one spot and you spin all the way around, you've completed 360 degrees when you get back and you're facing the way that you started. So that's one of the properties of circles. So we know basically that the sum of angle GFI, GFH, and HFI, when we add all those three up, should be 360 degrees total. So if we want to solve for x, all we're going to do is let's add up 100 plus 140 plus x, and that all has to be equal to 360. So pull up my calculator here and do 100 plus 140. So that's 240, and then I'm going to subtract that from both sides. So I've got 240 plus x equals 360. And so then x is equal to 360 minus 240. So my final answer for x should be 360 minus 240. You can probably do that in your head. I'm going to do it in the calculator just in case. 240. And that gives me 120 degrees. So my answer for part A on number 4 is 240 degrees is the measure of angle HFI. Put that right there too. Okay. The next circle, same exact principle, same process. We're looking at what is the measure of angle RQS. So that means that Q is the vertex of our angle. So when we go from R to Q and then from Q to S, we're looking for this angle right here. I'm going to call that Y. Same exact process. So all of these angles have to add up to 360. All these central angles have to add up to 360 degrees. So we've got 80 plus 80 plus 65. Oops, that's an ugly 65. 65 plus y has to be equal to 360. So again, we'll add up 80 plus 80 plus 65 plus 65. So that gives us 225. 225 plus y equals 360. So y is equal to 360 minus 225. I'm showing you all the steps here. I'm sure many of you could do this in your head, or you could do it in fewer steps, but I just wanted to show them all just in case, so you see exactly where I'm coming from. So we got 360 minus 225. Whoops. And we got 135. So my final answer here, y is equal to 135 degrees. That is the measure of angle RQS. All right, so number 5 is looking at something slightly different. This is another type of angle that we deal with circles. These are called inscribed angles. And what's special about inscribed angles, well, there's a couple properties of them, but for their definition is an angle that lies within a circle where the vertex of the angle lies on the circle itself. So you could think about it either as an angle which all 3 points that we're defining the angle from lie on the actual circle, or you could think about it as an angle that's made up of 2, so we call these chords, these line segments right here. These are not diameters, they're not radii, They just intersect the circle at two distinct points. And so you could also think of an inscribed angle as an angle made up of two chords where the vertex of the angle lies on the circle itself. And so the special property of inscribed angles that we're going to deal with in these questions is that the measure of an inscribed angle is equal to half of the measure of the arc subtended by that angle. And what I mean by that is this arc here from R to P on this circle, we're told, sorry, that's terribly drawn, but you get what I'm looking at here. We're told that's 194 degrees. So this is 194 degrees around the circle. And so the angle, the inscribed angle that makes up this arc, we know the measure of this angle is equal to 1/2 of the value of the arc itself, or the measure of the arc itself. So in other words, the measure of angle Q in this case, or I guess the measure of angle PQR is going to be equal to 1/2 of 194 degrees. So measure of angle PQR will be 194 divided by 2. So 97. So that angle right here is 97 degrees because it's half of the angle or half of the measure of the arc that's created by this angle. You could also think about this as, here's our answer there. So you could also think about this as if we had a central angle, like we talked about in problem 4, that went from the center to R and the center to P. The measure of this angle right here would also be 194 degrees, right? It's equal to the arc that's swept out by that angle. And so another way you can think about it is this inscribed angle here is equal to half of the measure of the central angle that's created using the same arc, if you want to think about it that way. So let's look at B really quickly. B is very similar. We're given an inscribed angle here, DCB, and it creates an arc of 144 degrees. So we know that the measure of angle DCB is going to be equal to 1/2 of the arc that is created by that angle, so 1/2 of 144 degrees. So the measure of angle DCB should be, again, I don't like doing mental math on videos because then if I make a mistake, I can't go back and fix it. Well, I could also put it in the calculator wrong though. 144 divided by 2, there we go. 72. So 72 degrees is the measure of angle DCB here. Again, it's just 1/2 of the measure of the angle that's created by the 1/2 of the measure of the arc that's created by this angle. All right, the last one's a little bit more tricky, but this is just combining what you know about circles and triangles here. So we're given that this arc right here is 88 degrees. So we know that this inscribed angle over here, x, is going to be 1/2 of that. So the angle x here, because this is an inscribed angle, it's sitting on the circle. So x is going to be equal to 1/2 of 88 degrees, which that one I'm comfortable doing in my head. That one's going to be 44. So if x is 44 degrees, the next thing we need to figure out is y. And so what we're going to look at for that is, there's a couple ways I think you could approach this one. It would be helpful if they told us that this is definitely a diameter here, with A at the center. So I think it's safe to assume that A is the center of this circle. And so we know that these two line segments right here are radii. The only thing that would be nice to know is that they were definitely parallel, but I guess since this whole thing is a triangle here, we're safe to assume that these two radii are parallel, because you can't have a triangle with an angle. There couldn't be an angle right here. In other words, these two need to be exactly 180 degrees apart. So if you think about from some point on the circle to A to some other point on the circle, if there was an angle here, if this wasn't completely straight, then we wouldn't have a triangle here. We would have quadrilateral. We would have 4 sides. So that's how we can safely assume, I think, in this case, that this right here is a diameter. And so if this is a diameter, we know that this is 180 degrees, right? It's half of the circle. Half of the circle's over here, so this arc is 180 degrees. From here all the way around to here is 180 degrees. And so if we know that, then we know that this inscribed angle y is going to be half of that, so half of 180. So we know that this is 90 degrees. Y is going to be equal to one half of 180 degrees. So that means y would be 90 degrees. Whoops, not 99 degrees. So y would be 90 degrees. And it looks like it's 90 degrees, but you can't just assume that it's 90 degrees just because it looks like a right angle. So we've got to actually make sure we have a reason to say something like that. So in this case, x is 44 degrees, y is 90 degrees.